A few months ago, I uploaded a video to YouTube where I made an Android Auto device using a Raspberry Pi and a touchscreen. However, for some reason, that video became the most defining piece of work I have ever created. And because of that, I suddenly have a reason to turn what was a half-functioning computer into something fully functional and something with form. This is the Bangray Digital Raspberry Pi Android Auto in its final form. Now, I'm no real engineer, but I sure can pretend to be one, and there are a few things that I need to do in order to get this device functioning better than it was in the end of the last video. A base, a body, and a battery. The first two items are necessary to complete the original build. However, the battery is something extra that will help with the function of the device. But before we get to tearing my car apart, there are a few things I need to cover. Starting with, what exactly is Android Auto? Android Auto is the Google version of Apple CarPlay. Android Auto works by running the Android Auto software on an Android phone, version 9.0 or newer, and sending that information to the car's computer. This operation is comparable to an HDMI or DisplayPort. However, the same operation can be done wirelessly through Bluetooth with Android devices 11.0 and newer in cars that support wireless Bluetooth connection for stuff like Android Auto or Apple CarPlay. Keep in mind, if you are using this feature over a cable, make sure you have a USB cable that supports data transfer and not just power transfer. One of the big questions is, does this device work with Apple CarPlay? The quick answer is no. Crankshaft only supports Android Auto. If you are looking to make a similar device and you have an iPhone or plan on using an iPhone, then my alternative to Crankshaft is a software called Huddy. I don't know much about Huddy other than that it does cost $10, making it not free, but if you're already paying for parts like this, $10 is just a little extra. And in addition, the general interface that isn't Android Auto or Apple CarPlay does look a little nicer than Crankshaft and is customizable with stuff like odometers and stuff that you can hook up into your car so that your car and the device you're using can accurately display your speed or your fuel. I don't know what you can actually get out of a car's information, but stuff like that.
Another thing is that some people even suggested running a local media server off of Crankshaft.
And while running a server off of Crankshaft seems like a cool idea, Crankshaft environment is rather ugly and I'm not trying to hang out there for too long in general. Plus, I'm only really there for the Android Auto.
In addition, if I wanted to do something like that, I do have an iPod running Rockbox that I can load any media file onto, as well as a working CD burning device.
Two more smaller things. Someone in the last video mentioned that the little springy things that were a part of the screen that I got are actually what are known as pogo pins, and in fact transfer electricity from the Raspberry Pi to power the screens, which means I can go ahead and get rid of those red and black cables that I was originally using to power the screen. And this one was just me, but I'm using a shorter ribbon cable so that the overall design is more compact. So with all that out of the way, let's do this thing. Starting off, of course, with figuring out what sort of parameters I need to actually get this screen integrated into the car. So, let us tear my car apart. I initially wanted the screen to replace the stereo unit / in-dash factory unit like what most modern cars have, so that the audio system could directly plug into the vehicle. However, from my extensive and professional panel removal, I discovered that, for one, it did not fit into the existing slot, and two, I really had no idea how to integrate it into the car's system. Well, yes, I could, with minimal amount of research, find a product that could turn the Raspberry Pi's GPIO pins into a left and right audio channel with power that would leave me with just a screen without a volume dial and a way to plug it in. And while yes, there are Bluetooth options, I'm not sure I'm going to want to have to uninstall all of that just in case I need to do some maintenance on it. So since we're not putting this into the car, what exactly is my alternative? Well, one that isn't exactly that pretty, but is very practical. A poorly cut wooden block with foam and duct tape. Now you're probably wondering, what the f***? And I'm right there with you. So let me explain to you how exactly wooden block with foam and duct tape wrapped around it integrates into this system. After I put my vehicle back together, I had to figure out how to mount a display to my car. So what is something in this car that's sturdy enough to, say, put something inside of it? Well, right below the CD player is a curious cavity that has enough room for, well, you guessed it, a wooden block with foam and duct tape wrapped around it. Now, a wooden block with styrofoam and duct tape wrapped around it is not a very advanced mechanism. Rather, it's a base for something to go into the curious cavity and, say, have a frame screwed into it. What I wanted to do was to have a device that could be really easily removed. Something that I could just pull out in case my parents wanted to use this car for something else, or if in the future I plan to resell this old lovely vehicle, I can just remove all the internals and not have to worry about losing the devices that are already in the in-dash unit, such as the CD player and, well, the curious cavity this wooden block is going into. So I went out and got some measurements on the space I would have available to mount this thing into the car. I then threw out my notes because I'm an art major and the only math class I took in college is sociology of statistics. Bruh. What is the mean and median of the size of this 2.5-inch hole? Anyways, I went to my backyard to try and find a wooden plank that was roughly the size that I had my caliper set to. So the hole in the car is actually not nearly as wide as this is. I took some bad measurements. I gotta kind of slice like 1/3 of an inch off of the wood itself. Trying with a different styrofoam because I was tired of this crap getting all over the place. And here's the final design with the new foam. Next, we needed a new frame. And please bear with me for this part because I have no experience in CAD or really any sort of body engineering, nor do I have any sort of CAD software. So for this, we're gonna be using Blender. Yeah, Blender. I started with trying to get the parameters in Blender to scale to millimeters, but that didn't seem to really work, so I decided to just eyeball it and try to scale it in the second program. I then built a base roughly the size of the screen I was using with little arms that I could drill into, then I could put screws into that will screw into the screen, in turn attaching the screen to the frame. Now that I had a general size, I needed to load that object in a Chewa box so that I could give it some supports and then slice the model so that it could be 3D printed. Thankfully, a while back, one of my dad's friends was getting rid of a bunch of resin 3D printer equipment. This included an Igloo Saturn S, a wash tank, and a curing turntable. My dad did have his own Igloo Mars 2 previously, which is how I learned to use the resin 3D printer. But obviously that 3D printer would be quite a bit too small to be able to print a whole frame. So what did I end up doing with all this stuff? Well, I had the genius idea to pull it all out, put it on top of the dresser that's located in my room. Cat, am I gonna get lung cancer? Where's my bed? Right up there. Finally, I ended up holding the 3D print plate to my screen and scaling the digital 3D print plate to the size of the real print plate. So then I could accurately scale the digital frame to the size of my real custom LCD screen. After a semi-failed first print, I was still able to realize that I needed to scale the model up by 5% and give me a second chance to improve the design. I attempted to make a design that would act like a door that would conceal most of the hardware. Something similar to the mechanism you would find on desktop PC side panels. It was somewhat sloppy and the print was an epic fail, but the mechanism still came out enough to give me enough data to determine that the door mechanism was not going to work. Despite all this progress, we need to put a pause on modeling the frame. And that's because in part 1 of this video, we used a Raspberry Pi 3B Plus in order to run the crankshaft software. And I had the device set up so that it would turn on as I turned the car off and turn off as I turned the car off. However, quite a few people mentioned that this sudden loss in power to the SD card can actually be quite damaging. And so I had to find a solution that would allow me to power the device down even after the car was off. After some research, I found that the device that I was looking for is called a UPS battery. A UPS battery is a device that sits idle in a system and waits until, say, the power is cut, until which it will then start powering the device. In a computer, this can be a backup battery that gives you enough time to properly shut down your device so you're not losing any sort of data. In larger systems, for buildings such as hospitals, this can be a small room-sized array of just batteries that wait for the power to drop and continue supplying power to necessary electronic devices such as life support before the giant generators you usually see at hospitals kick in. And in my case, I just needed a small battery that would, like I said, keep the device powering even if the car is turned off. So that if I do end up turning off my car before I turn off the device, it will continue running so that I can easily and conveniently unplug my phone and go through the shutdown sequence for crankshaft. And of course, all of that just to protect the micro SD, which is pretty reasonable for this economy with micro SD and SD cards costing a fortune to purchase. So let's try and, save as much as we can. After a bit of research, I landed on a power supply UPS hat for Raspberry Pi, a device that connects to the Raspberry Pi via the GPIO pins and holds two 18650 batteries. And you're probably wondering, well, Ben, why can't you just turn the device off before you turn the car off? It does take like 3 seconds to do all that, and the battery pack wouldn't really give me that much more time than just leaving the car on. I did encounter another issue that allowed the battery pack to actually have some additional benefits into the system functioning more seamlessly. More about that in just a little bit. To demonstrate the usefulness of this battery, I'm gonna use Android Auto in the middle of this lake. If I drop this whole device is fucking fried. It's taking its sweet time. Oh, here we go. Okay, so now we're in the crankshaft environment. I'm gonna go ahead and plug in my phone here. Hold on, it's connected. Oh, here we go. See? We're in the middle of the lake. Yeah, there it is, running Android Auto off of these two batteries. So, point in case, they're very useful if you wanna have your own running device. And now that I have the full depth of the device, I can resume my creation of the frame. I tried the computer panel door mechanism one more time with a new depth in mind and got this really interesting result, but soon figured out I would probably be better off just scrapping the whole thing. That's when I decided to take a different approach: magnets. I ended up making a rectangular frame and made the left and right sides slightly thicker so that I could leave little holes in it that I then could insert magnets into. I included some slots so that the cords could come in and out of the sides where they were needed, and rounded the corners so they weren't as sharp. And more importantly, an open backside that didn't have a door. I printed that John, and for the first time, it finally came out perfectly. So how exactly do I attach 3D print resin onto another material? Well, remember how I mentioned magnets like literally 1 minute ago? Well, what I had in mind was a wooden frame that I could screw similarly sized holes into and just get 2 times the amount of magnets as I made holes in the 3D print for, so that the 3D printed resin frame and the wooden frame could just snap together like one thing. To which the wooden frame could be screwed into the wooden block with styrofoam and duct tape wrapped around it that could be then inserted into the car. Do you see where I'm going with this? More on that in just a little bit. So magnets. The 3D print came out and I realized the hole was about 3/16 of an inch. And so I was like, well, I wonder who's going to have magnets about that size. In my mind, there was no way that there was a company that made magnets that size for regular consumer shoppers. Lo and behold, Grainder.com, not sponsored, had some neodymium engraved 35 disc magnets for exactly 3/16 in diameter and 0.12 inches deep, available in bulk for 56 cents a piece. So if there's 16 holes on the frame and 16 holes on the 3D printed frame, that's about 32 magnets, so I then ordered 38 of them. You know, just in case I do mess things up. The best engineer is the one that prepares for their errors. That's subtle foreshadowing, by the way. Anyways, with those magnets on the way, it's time to build the wooden frame. And I honestly didn't really know where to start with this part, but luckily I was in a 3D design class that had a bunch of tools that I could use in order to bring my idea to life. I started with finding a board roughly the size of the frame, measured out the sides onto the board, and then I used a saw to then cut those segments into something that I could attach somehow and which would eventually create a frame. Sanded the pieces a little bit and then wondered how exactly I was going to attach such narrow pieces of wood. Well, I made some very good use of a 23 gauge pin nailer. Got all the sides actually looking really good and then realized the frame was just slightly too small to fit the 3D printed resin frame. So after that, I ended up just cutting some more wood and resizing it, using 2 of the pieces from the original frame and attaching those in, and turned out, well, pretty good. Then needed to figure out where and how I would put the holes into the wooden frame so that the magnets could go in there as well. That I used a pretty narrow drill bit and kind of honestly just eyeballed the depth of the holes. As you'll see in the end result, they're very uneven and really sloppy. So don't blame me, it's not great, but it works. And after a little bit, I had roughly the same amount of holes I had on the resin 3D frame. Now it's time to insert the magnets. Now you would think inserting some small magnets into some holes using super glue would be rather straightforward and fairly easy. I quickly learned that that is quite the opposite of what it's actually like, and well, here's what that looks like. So this is the test to see if any of this is actually even worth it. 3, 2, let me make sure it's right. 3, 2, 1, and all right. That's pretty solid. Could be making better contact for sure. Other than that, as you can see from my test, it ain't really going anywhere. Actually pretty well. So now all there's left to do is to, I guess, paint this black and get it mounted into the car. And after a lot of trial and error, I eventually got all the magnets into all of the holes with a lot of glue on my finger, but the job was done. After that, I then spray painted both of the frames so that it can kind of conceal the less than optimal look of, well, quite frankly, all of it up to this point, and sanded the edges a bit more so that would be a little rounder and less sharp on the hand. I also threw some heat sinks onto the Raspberry Pi so it has some ability to cool itself, especially now that it's summer. And with all of that done, I think it's about time to try and actually integrate it into the car. Since I'm not hardwiring this device into my car, I've got to find an alternative in order to get the audio into the car speakers themselves. And that started with upgrading this Bluetooth to FM converter. This device is quite nifty if you have an older car like me. With this device, you plug it into your 12-volt cigarette lighter port, and from that you can tune your car's FM channel to be the same as the one on the converter. From there, you can then connect your phone's Bluetooth to this device, as you would, say, any other Bluetooth device, and boom, you then have car speakers that you can connect your Bluetooth to as if the car was made in the past 2 decades. With that being said, why exactly am I upgrading? Well, a while ago I was using a Bluetooth to FM converter that did not have a 3.5mm audio jack on it. And my initial assumption is that, well, if I get a Bluetooth to FM converter that also had a 3.5mm audio jack on it, I could then just route the audio output from the Raspberry Pi into this and it would work like a charm. However, I soon discovered I did need the audio jack, but for a much weirder reason. And for a bit of background information, the way Android Auto works is it routes the audio through the cable that you're plugged into, or Bluetooth if that's what you're using, so that the audio could then go into your car's computer and then in turn to its speakers, because Android Auto assumes that the car it's plugged into is also connected to its speakers. And here at Bangray Digital, we truly make sure that technology is used in ways that's not really supposed to be used in. What I discovered is that when I play audio from my phone and it's connected to the Raspberry Pi, in turn, Android Auto is trying to route the audio through the Raspberry Pi. But the Bluetooth connection is still connected to the Bluetooth to FM converter. And here's the part I don't really understand. When I attempt to play music with my phone while my phone's connected to the Raspberry Pi, but the Raspberry Pi isn't connected to the Bluetooth to FM converter via 3.5 audio jack, but my phone is still connected to this device via Bluetooth, I can hear a very faint but mostly inaudible version of my music, like a really just turned down version of it. However, in the same situation, but now the Raspberry Pi is connected to the converter via the 3.5mm audio jack, the volume of the music is now at a nominal level, something that can actually be used, which is very weird. But that doesn't mean that the audio is coming from the Raspberry Pi. And that's because if I have the Raspberry Pi plugged into the converter's 3.5mm audio jack with the phone plugged into the Raspberry Pi, but the phone's Bluetooth is not connected to this, the audio is completely lost. It's almost like plugging the Raspberry Pi into this converter via audio jack acts as some sort of switch for my phone's Bluetooth to work at full volume. It's the weirdest thing. But with that being said, at the end of the day, I suppose it is working, which is what we want. It's just there's a lot of audio jack cables involved, which isn't the prettiest sight ever, but it's manageable. Now, remember what I said about the battery a few minutes ago when you maybe asked, why can't you just turn the device off before you turn the car off? Well, another issue arose while testing the device without a UPS battery hat. I tried to use the Raspberry Pi just plugged into the car without any UPS battery hat. And what I noticed from that is that it created a significant amount of static noise, significantly more compared to when you had the battery pack on. Unfortunately, however, one does not simply charge the battery pack by just plugging the Raspberry Pi in through the normal USB port, which means the only way to charge the batteries without taking them out and plugging them in elsewhere inside my house, for example, is to use the standard wall outlet plug that they give you, which meant if I wanted to have the batteries charged all the time so that the Raspberry Pi could have optimal voltage so that there wasn't a bunch of static noise, I would have to use a standard wall plug inside of my car, which meant it was time to look for a DC to AC converter for the cigarette port in my car. Thankfully, I did have a second cigar lighter port inside of the center console in my car, so I did have the room to put in a DC to AC converter. And so I did just get a cheap converter off of eBay, threw it in there, and it did seem to work fairly well. And after putting the converter into the car, plugging the batteries into that, and routing the wires underneath some of the interior panels, it was time to put this thing to the test. Come with us for a ride. What's going on up here? This light. That's pretty smooth. All right, here we go. Right turn. Look at us go. Oh, my left turn.
So I made it to my destination. I'm gonna go swimming real quick and I'll be back. All right, let's get back to it before they tow my Mission accomplished. The device has been used and I went to the lake. I got to splish and splash, so I'd say it's a win-win.
For powering.
All I did was plug in the wall outlet plug into the little DC to AC converter. This is the shit I'm talking about. Okay, it went away. I don't know, man. I'm sorry. I wish I could explain any of this. Okay, let's go. And while this is the final product for this project, I'm not fully sure of the end result. Don't get me wrong though, this is the most advanced thing I have ever made. And while the device does work as intended and the engineering allows it to be easily inserted or removed, at the end of the day, with everything going on with it, it is extremely inconvenient. For starters, Android has all sorts of problems. There are times where Android Auto just totally freezes up and I have to then unplug my phone and re-plug it in just to try to get Android Auto to boot again while I'm trying to drive. And that could be either a result of Google's weak-ass tensor or a result of the Raspberry Pi. But because of the way Android Auto works, it's probably the former. Thanks, Google. Secondly, this is an older car. And because I chose to not directly hardwire the device into the vehicle in order to keep the device easily removable, I've had a lot of problems with auditory digital noise from the speakers due to the Bluetooth to FM converter. There are a few reasons this is happening, and unfortunately the worst part is there is not much of a fix for it. Two things cause this. The first is the given nature of the Bluetooth to FM converter. I explained the way this device works earlier, just not the downsides. If you personally own one of these devices, you have probably experienced their weakness firsthand, and that is other people. Driving any substantial distance while using a Bluetooth to FM converter, you will experience at least one of two things. Driving past other people using a Bluetooth to FM converter on the same frequency you're using. This is a more minor inconvenience because usually when you're driving on a road, you pass people or people kind of go their own way, so it's a pretty small inconvenience. You know this will have happened to you if suddenly your music kind of combines with somebody else's music very briefly and then goes back to being your own music. The second issue with Bluetooth to FM converters is actual radio stations. While the town you reside in usually has a few radio stations that broadcast on their own frequencies, the next town over is going to have completely different stations broadcasting on completely different frequencies. This means that in your hometown, if you have a specific frequency you like using because it's pretty clear, and you take a drive to the next town, odds are you're going to have to then change the frequency both your car's FM receiver is on and Bluetooth to FM converter is on. And in addition, radio station frequencies usually are broadcasted at a significantly higher power, meaning every single time you encounter a radio station frequency, it will always overtake your little Bluetooth to FM converter frequency. With that being said, that isn't that big of an issue. Just pop over a few stations and, it's just something that's kind of inconvenient when using that device. And even though those two issues are not that big of a deal, it just adds to the inconvenience this device brings. Now going back to the overall issues, the build of the device causes the screen to sit really far forward. This makes it kind of awkward to try to press anything on the screen. I would say it's fairly similar to just looking at your phone in the sense of taking your eyes off the road in order to change something on the screen. Compared to a modern car with a screen built into the dashboard, that screen sits much more on the dashboard, so you take your eyes off the road much less when you're looking at an actual car screen. And you know what, with all that being said, everything I purchased will be linked below. So if you want to make something similar or even better, please be my guest. In addition, the 3D model frame that I made will be in a Google Drive if you wish to download it and try and do something with it. I will note, as I said before, it is not properly scaled, so if you try and do something with it, just good luck. It definitely would have been scaled correctly if I used an actual CAD software, but I digress. And so in conclusion, this is not the end. I want to do something like this again in the future where I have better skills or tools or resources to actually make something that works with a car well. This has been a very fun adventure and I've learned quite a lot about many things because of it. Overall, it has been a net gain. But anyways, this has been Ben Gray Digital. Thank you for watching, and I'll see you in the next one.